Hello everyone and welcome. In this short video we will be solving another LeetCode problem with APL. We are going to solve problem 11.8, defanging an IP address. And the problem statement is fairly simple. We are going to be given a valid IPv4 IP address and we need to return its defanged version. And they define this defanging operation as replacing every period with a period enclosed by square brackets. And they give us a couple of examples here. So this address becomes this thing over here, and this address becomes this thing. And so solving this in APL is really simple. And the first solution that pops to mind is actually using regular expressions. So let me define an IP address to play with. So this is our address. And the Regex solution is really simple. What we just say is we are going to look for a period, and we need to insert the backslash here, otherwise the period in regular expressions means any character, and we want the actual period. So let's take any period and replace it with this. And now let's apply that to our address. And this is a very simple solution, so our first solution could be just this. But as it turns out, and I did a little bit of testing beforehand, so our solution is just that. As it turns out, regular expressions, they work well, but they're not necessarily very fast, and so there's plenty of ways to solve this in faster ways, or with faster algorithms. But the very first one that pops to mind is actually using APL's primitives to do something similar to what the regular expression is doing. And so we are going to use the @ operator to replace the dots with these things over here. So let's write our second solution, and that is, let's take this scalar. So actually let me remove the parentheses to show it to you. So this is a string. So this is a string, which is actually a vector of characters. And now I'm enclosing it to turn it into this little box over here, which means this is now a scalar. So I can look at this as a single element. So what I'm doing now is, let's take this scalar and insert it at the positions that are equal to a dot. And let's do that in our address. So what happens now is we get this vector over here with these little boxes where I have the numbers, and then each number is separated in a box, and then there's boxes that contain all of this. And this is why I needed to enclose that. Otherwise, if I don't enclose this over here, what's happening is each dot is being replaced with one of the, sorry, this is not what I wanted, so let me do this, and let's stack them up so I can show you. So what's happening here is, because this string is 3 characters long, so this vector has 3 elements, and because the address has 3 dots, what's happening is the @ is replacing each dot by a successive element. And this is not what we wanted. We actually want everything to be put there at once, and so that's why we enclose it. And now we can see that each dot is being replaced by this. But now this is not a simple vector. This is a vector with vectors inside, and so we need to flatten this, so to say. And the way we can do this is we can actually use the enlist function, like that. And the enlist function removes the structure and just gives you a vector. So this is a solution that is very similar to the regular expression one, but this one should be faster. So let's save it. So this is the enlisting of these replacements. So equals dot. Now let's test our solution. And now what we can do is use the runtime user command to compare our first solution applied to our address and our second solution applied to our address. Press enter, we give it just a little bit of time to run, and then there you have it, these two solutions compared, and we can see that the regular expression one took around 3.7 to the times 10 to the power of minus 6 milliseconds or seconds. I think this is seconds, I'm not entirely sure. And then we can see that our second solution was about 3 times faster. But this is not, I'm sure this is not the fastest solution you can come up with. So if you want to give it a go, try to come up with a faster solution, and then maybe write it in the comments below, or make a pull request to the GitHub where I'm hosting all the solutions. And yeah, let's add your proposed solutions to that repo. So feel free to give it a go and make a pull request, and otherwise I'll see you in the next video. Bye.